Hello everyone. This video is for 1.3. So here we go. Let's do this color and this one. Okay, now we're ready. So this basically we're talking about the square roots of a non-perfect square. Now, for example, now how about the root of 19, right? So compare with that, of course, root of 25, because 25 is a perfect square, so that is 5, right? Or root of 16, and 16 is also a perfect square, so then that is 4. So these ones, this one, and the root of 16 and root of 25, then is 1.2. Now 1.3, we're trying to think, okay, how do I do about the root of 19? Now, of course, if you use a calculator, that's not a problem. Punch in and get the decimal number, and that's fine. But in this section, we're going to just learn one thing about how we can approximate to estimate what the root of 19 should be, how much it should be vaguely, right? Approximately how much it should be. So that would strengthen our number sense. Now, in the textbook, we talked about this method, and this is just using a formula, which I find is too boring because it doesn't even tell us how the formula came about. So I don't want to do that. Now, next one is using an algorithm, okay? Now, you think about look at the steps, this many steps. And you look down here, and I think this is also ridiculous. Don't like this either, unless we understand how the algorithm work. But for your grade level, let's skip that too, okay? So now I just want to quickly demonstrate. Because nowadays, seriously, we can just use a calculator, but some of the logical thinking behind the estimation could be useful or meaningful, so then I just want to share with you. Now, for example, we just talk about the root of 19, all right? So in this case, we want to locate two perfect square number. So if we got a 19 as a number here, so we wanted to find the next larger perfect square. So then that will be 25. All right. Now the left hand of 19. So it's a perfect square that is smaller than 19. Then we can think of is the 16. All right. So then the 19 is in between 16 and 25. So if we square root of 3 numbers, now this one equals to 4, this one equals to 5. So now, very naturally or logically, we can be sure root of 19, square root of 19 will be somewhere in between 4 to 5. So it will be 4 point something. Now 4 point what? Now take a look at here. From 16 to 19, there's 3 numbers in between, right? From 19 to 25, there's 6 numbers in between. So therefore, definitely this will be smaller than, so this number should be smaller than 4.5. I hope this makes sense to you, right? So then in this case, so how can we estimate this just to say 1 decimal place? That's fine, we'll just do 1 decimal place. So it should be 4.1, 4.2, 4.3, 4.4. Anyways, we know that it should not be 4.5 for sure. So then what do I do? So the way we do, we can think about from 16 to 25. Now how many numbers in between here? there are 9 numbers in between, right? There are 9 numbers in between. So then from 16 to 19, from 16 to 19, now how many numbers there? That's 3. So from here to here, that is 3 over 9. Then that is 1 over 3. Oh, nice. So in that case, 1 over 3 is 0.33. So then, okay, then therefore, the root of 19 should be approximately be 4.3, right? Or use another way to write is approximately, it is 4.3. And this kind of estimation, I find it's simplistic, it just makes sense. And as far as we can estimate it to this kind of level of accuracy, then we should be perfectly fine. All right, so now take a look at exercise set, okay? Now these numbers, you pretty much will be able to see the square root of them, whether or not that would be a rational number or irrational number. Irrational number means non-repeating decimal. The decimal is going on and on and on. Okay, and these questions you should be able to do it without too much a problem. Now here, without using a calculator, determine to 1 decimal place. You see this? To determine to 1 decimal place. So this is using the one that I just talked about. You should be able to do it. Now, of course, these numbers are larger, but bottom line is still look for a perfect square on this side and look for a perfect square on the other side. Then you should be able to use the space in between and the ratio of the space to figure out the estimation. Okay, now don't worry about this. Okay, and then the Pythagorean theorem. I believe that everybody knows this. Do some practice here just to recall how to calculate them. Now, this question is interesting. Now, take a look at this. Now, further, this question is very interesting. Okay, so I'd like all of you to definitely do 8, 9, 10, 11, please. Okay, so this question is very important. Well, thank you for watching.